Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Deep beneath your feet, farther than any shovel can dig and deeper than the deepest cave, there lives a world you will never see. It is not dark in the way we think of night. It is not quiet like a room with no sound. This place pulses with a heat older than memory, glowing in colours your eyes cannot imagine. It is the molten heart of the earth, a spinning core of iron and fire that never sleeps, never cools, and never forgets what it is. You're walking every day on a crust so thin compared to this deep ocean of heat that it's like the skin on hot milk. Yet that skin, our continents, our oceans, our homes, floats gently on this burning sea. No one has ever touched Earth's core. We cannot dig there, not even close, but we know it exists because of the way the planet trembles. When earthquakes happen, they send waves through the Earth, like ripples in a pond. Scientists listen to those ripples with machines like stethoscopes, and the way those waves bounce, bend and change tells us about the hidden world below. The waves slow down, speed up, or even stop depending on what they travel through. And when we study their paths, we see a picture painted in tremors, a solid inner core wrapped in a swirling liquid outer core, surrounded by a hot rock, all spinning slowly beneath us like the gears inside a quiet clock. This core is made mostly of iron and nickel, heavy metals born from ancient stars. Billions of years ago, when Earth was still young and soft, these metals sank inward, drawn by gravity's steady hand. As they settled in the center, they packed tightly together and the pressure grew. Imagine standing under a mountain so tall that it touches the sky. Now imagine that mountain pressing down from every direction at once. That is the kind of pressure inside the core, squeezing the metal until it glows. Even though it's hotter than the surface of the sun in some places, the inner core stays solid because of the crushing pressure. Around it, the outer core is molten, flowing, dancing, spinning like thick honey on a slow fire. And this slow, fiery dance does something extraordinary. As the molten metal moves, it creates a magnetic field that stretches far beyond the Earth itself. This invisible shield surrounds our entire planet, reaching out into space like a soft bubble. It protects us from the sun's dangerous winds, guiding them safely around us instead of letting them strike the Earth directly. Without this magnetic field, the sun's radiation could strip away our atmosphere, as it did to Mars long ago. You can think of the core not only as Earth's furnace, but also as its guardian, a silent protector that shields us with forces we cannot see. Sometimes the molten core stirs in stronger ways. It pushes and pulls on the rock above it, making the Earth's crust stretch and crack. These cracks become deep faults, and the movement creates mountains, rifts, and even earthquakes. Over millions of years, this inner fire reshapes the face of the Earth. Continents drift like slow rafts on a glowing sea. Oceans widen, mountains rise. Volcanoes form where the fire finds a path to the surface. And always beneath it all, the core keeps turning, a heartbeat measured not in seconds but in epochs. It is easy to forget this story when we stand on cool ground or walk on tiled floors. But the heat that once melted the Earth is still here, deep below. It is part of your story too. Every time you hold a compass, it points because of the core. Every time you look at the sky and see dancing lights in the north, they are shaped by the magnetic winds that spiral from this inner sea. And every time you hear about an earthquake or volcano, know that the Earth is alive and its fire is still speaking, in tremors, in light, in molten whispers that travel from the center of our world to the soles of your feet. This hidden heart has been beating since before any life walked the Earth. It has outlasted ice ages and asteroid strikes. It is the reason we have mountains to climb and valleys to shelter in. It keeps time not with ticking, but with the slow swirl of liquid metal and the quiet pulse of heat that will not fade. You may never see it. But it is always there, holding the world together from the inside out, a silent fire beneath your every step. Now imagine drifting deeper, as if the Earth were transparent, and you could float gently through layers of time. The further you go, the warmer it becomes, not with the warmth of sunlight, but with the heavy, ancient warmth of memory. Here the rocks remember things. They remember when continents were one, fused together in a supercontinent called Pangaea. They remember when seas covered deserts, and volcanoes painted the sky with ash. All of it stirred by the same force, the silent fire within. This heat, born when the earth was born, never truly leaves. It rises in slow waves, feeding the restless breath of the planet above. The molten outer core does not sit still. It moves in great loops, heated from below by the solid inner core and cooled above by the mantle. This motion is called convection, like warm soup swirling gently in a pot. As the hot metal rises and the cooler parts sink, this flow becomes a silent engine. And this engine spins faster near the equator, slower at the poles, shaped by Earth's own rotation. From this constant motion, the planet's magnetic field is born. You can't see it, but it touches everything, guiding birds as they fly across oceans, helping whales navigate the deep, even leaving traces in ancient rocks that once pointed north and now sit sideways in a mountain spine. And still, beneath that is the solid core, about the size of the moon, but heavier than all the oceans combined. It is not just a ball of metal, it is a memory in motion. Some scientists believe it is growing. As the Earth slowly cools, parts of the molten outer core crystallize, adding to the solid heart. Like frost forming at the center of a deep pond, this growth changes the way the core moves. And as it changes, the magnetic field flickers. Sometimes it even flips. North becomes south, slowly, over thousands of years. The last time this happened was long before humans were born. But the rocks remember. Lava that cooled in those ancient days holds a magnetic map, a frozen compass that still points to where north once was. The mantle above the core is solid but not still. It flows very slowly, like glass that has not yet hardened. This flow too is shaped by the fire below. Where it is hotter, the mantle rises. Where it cools, it sinks. This drives the drifting of continents. It is why Africa is slowly moving north. It is why the Himalayas rise higher each year. It is why the Atlantic Ocean widens, grain by grain. None of this happens quickly, but over millions of years, mountains can grow like waves on a stone sea. Valleys can open like sighs, and volcanoes can rise, sleep, and rise again, all fueled by the slow breath of the Earth's fire. There are places where this fire gets close enough to touch. Iceland, Hawaii, Yellowstone. Here the heat swells near the surface. Geysers spout like exhaled steam. Lava flows, shaping new land. These are the places where the earth whispers its secrets. The ground is never silent. It rumbles softly, sings in vibrations, carries messages in the slow language of heat and stone. If you could stand still and listen with your bones, you might feel it. A rhythm beneath your heartbeat, a hum that rises from the deep. And in all of this, there is balance. The heat within does not rage wildly, it moves with purpose, slowly, deeply. It melts rock, but it also builds land. It shakes the ground, but it also makes soil rich. Without the core's heat, the earth would be quiet, cold, and still. There would be no magnetic field, no plate movement, no mountains or valleys. Life as we know it might never have begun. The fire did not only shape the earth's surface, it may have helped shape life itself. Deep-sea vents, warmed by this hidden heat, create chemical soups that some scientists believe were the first spark of living chemistry. Life may have begun in the dark, warmed by a fire that no sun ever touched. And so the core is not just part of the earth, it is part of us. It shapes the world above, but it also whispers through the ages. It tells stories in the angles of mountains, in the flow of rivers that follow faults, in the silence after an earthquake. It speaks without words, using pressure and time, and though it is unreachable, unknowable in some ways, it holds us gently, like a mother holding her sleeping child, keeping the cold of space away. If the earth is a living being, then the core is its soul. Not a soul made of thought or feeling, but of steady, glowing persistence. A kind of memory that burns instead of fading. A reminder that even in silence, even in darkness, something powerful can still endure, shaping everything from beneath, with patience, with warmth, with quiet, endless motion. Let us drift now to the quietest part of this journey, where the Earth's story folds into reflection, and the fire within begins to feel more like a memory than a mystery. The core, buried thousands of kilometers below the surface, will never be touched by hands or eyes, and yet it touches everything. Every step you take rests on a surface shaped by it. Every map ever drawn, every mountain climbed, every ocean crossed, all of them sit lightly atop the deep hidden engine that never asked to be seen, only to be felt in the slow shaping of the world. The journey of the core is not loud. It does not roar like the sea or strike like a storm. Its voice is in the turning of ages. Its fingerprints are left in rock layers, in magnetic swirls frozen in ancient lava, in the drift of continents that once danced together in a single land and now move apart like old friends walking in opposite directions. The continents are still moving. Even now, the floor beneath your feet is not still. It floats on a current so slow you cannot feel it, but over millions of years, it will shift landscapes, build new mountain ranges, and erase coastlines, and all of it begins with the core's gentle motion. As humans, we often look outward, to the stars, to the sky, to what lies beyond. But there is wonder within as well. The Earth's core is proof that mystery does not only exist in the distance, it lives underfoot, in silence. And this silence is not empty. It is full of time, pressure, memory, and movement. The heat there has never cooled, not since the Earth was born, and it may never cool entirely. Long after we are gone, long after our cities are ruins and our languages forgotten, the core will still be spinning, still shaping, still glowing in the dark. There is comfort in knowing that something so constant exists beneath us. When the world feels uncertain, when change moves too fast to understand, remember that deep below there is a rhythm that has never stopped. This rhythm is not fast or loud, it does not care for speed or urgency. It is slow, like a lullaby stretched across billions of years. And in this slowness there is peace. There is the reminder that some things do not need to rush to be powerful. Some things do their work quietly, over lifetimes longer than mountains. The magnetic field born of this core surrounds us like an invisible cocoon. It holds off the sun's winds, protects our atmosphere, paints the sky with auroras, those dancing lights that shimmer like ghostly curtains at the poles. They are beauty born from protection, a quiet gift from the fire beneath us. And this gift connects us to the animals who use it, the birds who migrate with it, the turtles who find their beaches by it, the bacteria who align their bodies with it in the dark waters of the ocean floor. The core links us all, across kingdoms and continents, in a web of unseen motion. Even our own bodies echo the earth. Our hearts beat like the earth turns. Our blood flows as the molten core swirls. We are not separate from this planet. We are made from it. The iron in our blood once floated in clouds that formed the Earth's core. The calcium in our bones came from rocks born in volcanic heat. We are walking memories of the Earth's fire, cooled just enough to speak and dream and wonder where we came from. And where we came from is here, not just the surface, but the centre. The fire inside the Earth is not far. Not really. It is part of your story, even if it stays hidden. It is the reason the world is warm enough to bloom, restless enough to change, steady enough to carry you. The next time you feel the ground beneath you, remember that it is not solid all the way through. It is alive with quiet energy. It breathes slowly, and that breath moves mountains. The core is a secret we all carry without knowing. It hums beneath every country, every ocean, every quiet field. And though you may never hear it, it is always singing, a song of weight and warmth, of patience and power. It sings to the moon as it pulls at the tides. It sings to the stars as it spins within a galaxy. It sings to you too, if you stop to listen with more than your ears. So close your eyes and feel the earth beneath you. Not just the cool floor or the soft soil, but the deep, slow-moving heat that holds it all together. This is the fire that shaped your world. This is the memory that keeps it turning. And though it burns in silence, it is never still. It waits. It remembers. It continues. A heartbeat beneath your own, glowing always and always and always. Beneath your feet, the earth is not a quiet, unmoving place. Far below the soil and the stones, beyond the deep roots of trees and the last homes of worms, there are slow, rumbling rivers of rock. These are the tectonic plates, massive pieces of Earth's crust, floating gently atop the soft, flowing mantle. But they do not drift like leaves on a still pond. They move with purpose, shaped by forces we cannot see and guided by the fire deep within the planet. Their motion is slow, inches per year, but unstoppable. And though they carry the world's continents like silent rafts, they also carry a secret. They whisper, they resist, they collide, and in their quiet friction, they shape every mountain, every ocean trench, every valley carved over time. The Earth's crust is broken into these great plates, like a cracked eggshell surrounding a molten centre. There are 7 large ones and many smaller ones, each constantly moving, nudging, pressing against or pulling away from their neighbours. These movements happen along boundaries, places where 2 plates meet. Some boundaries slide past each other like strangers in a crowd. Others push together like the slow meeting of ancient giants. Some pull apart like soft clay stretching under invisible hands. And in these places, where plates touch and press, the Earth becomes alive with motion. Mountains rise, oceans widen, and earthquakes tremble quietly beneath the soles of your feet. The whispers beneath the crust are not made of sound, but of pressure. As plates grind against each other, energy builds. This energy does not scream, it waits. It waits until the rock cannot hold anymore, and then it releases all at once. The earth shudders, a crack opens, the ground shakes. And this is how earthquakes are born, from the quiet struggle of stone beneath stone. In some places, like the edges of the Pacific Plate, these whispers are frequent and fierce. These zones are called fault lines, and they form scars across the Earth's skin. But even in the quietest places, the plates never stop speaking. Long ago, the continents we know today were not separate. They were part of a supercontinent, a single landmass called Pangaea. But Pangaea did not last forever. The plates below it moved, slowly tearing it apart. Over millions of years, the land drifted into the shapes we now recognize: Africa, Asia, the Americas, floating slowly on the back of a moving Earth. And they are still drifting, still whispering. The Atlantic Ocean, for example, grows wider by a few centimeters every year as the Americas move west and Europe and Africa drift east. It is a slow dance, but one that never stops. Volcanoes too are born from these movements. Where plates pull apart, magma rises from deep within the Earth, filling the gap with new rock. Iceland sits atop one of these places, a land still being born from the Earth's breath. Where plates push together, one may sink beneath the other, dragging rock deep into the Earth, where it melts and rises again as fiery lava. These volcanoes do not always roar. Sometimes they sleep for centuries, their mouths closed, their fires hidden. But deep inside, the pressure builds, the heat stirs, and eventually they speak, not with words, but with smoke and flame. And yet there is beauty in this movement. The tallest mountains, Everest, the Andes, the Alps, were all shaped by the meeting of tectonic plates. Each rise, each fold in the Earth's skin, is a record of ancient collisions. If you could peel back the layers of a mountain like pages in a book, you would find the story of 2 plates pressing into each other, neither yielding and instead rising together toward the sky. These mountains are not just stone, they are frozen motion, solid echoes of the Earth's invisible breath. Rivers are born in these high places, flowing from snowmelt and rain, carving valleys as they make their way down. The landscapes we love, hills, lakes, cliffs, are all shaped by the long patience of plate movement. And in this we see a lesson, that great change can come from slow, gentle force. The Earth does not rush. It shifts quietly, letting time do the work. And from this quiet motion comes all the beauty of our living world. These plates have been moving since the Earth began to cool. They are part of the great cycle that keeps the planet alive. When old crust sinks into the mantle, new crust rises elsewhere. It is not destruction, it is renewal. Like the tide of the ocean, the Earth's surface flows, not in hours, but in ages. And though we cannot see it and rarely feel it, we are always standing on ground that is gently, patiently in motion. These are the whispers beneath the crust, not angry, not wild, but steady. A conversation that has lasted billions of years and will go on long after we are gone. Let's drift deeper into the slow conversations happening beneath our feet. These tectonic plates, though made of rock, behave more like living things than we imagine. They breathe in their own way, stretching, pressing, folding. And between them, in the soft edges where one plate meets another, the Earth performs a patient, restless dance. Where they pull apart, new life is born from molten rock. Where they collide, the surface crumples and lifts into mountains. Where they slip past each other, the tension creates shudders that ripple across the land. And all of this happens quietly, day by day, year by year, without the need for anyone to notice. It is change written in the language of stillness. Imagine two great plates slowly drifting toward each other. One is slightly heavier, made of oceanic crust. The other is lighter, made of continental rock. When they meet, the heavier one dives beneath the other in a movement called subduction. It disappears into the earth, where it melts and feeds the fiery belly of volcanoes. Above this hidden clash, mountain chains rise, tall, proud, and ancient. This is how the Andes were born, how Japan took shape, how the islands of Indonesia formed like scattered beads on a string. Even the Himalayas, the tallest mountains on Earth, are still growing. Every year, as India continues to press into Asia, the mountains lift a little higher. They are the result of a collision that began tens of millions of years ago, and which continues today, as quiet and certain as the turning of the seasons. But not all boundaries are made of conflict. Some are gentle separations. The bottom of the Atlantic Ocean, the mid-Atlantic ridge, stretches like a seam in the planet's skin. Here, the plates move apart and magma rises to fill the space, creating new crust. This is how oceans grow. The seafloor spreads little by little, and with it the continents drift apart like rafts on a widening river. These spreading centres are places of creation. They give birth to new land, often unseen beneath dark waters. And though we cannot hear them, the earth sings here, in heat and salt and slow, steady motion. Then there are the sliding places, transform boundaries, where plates scrape past each other sideways. The San Andreas Fault in California is one of the most famous. Here, the Pacific plate slides northward beside the North American plate. They do not move smoothly. They catch, stick, resist. Pressure builds for decades, sometimes centuries, until suddenly it is released in a quake. The ground jumps, buildings tremble, roads split like torn paper. But even in this violence there is purpose. The earth is releasing tension. It is speaking the only way it knows how, and in motion. Over time, the movements of plates leave marks not only in the land, but in the rocks themselves. If you look at ancient mountain ranges or folded layers in stone, you are seeing the history of motion. Rock that was once flat, now bent and lifted. Fossils found on different continents match each other because those lands were once connected. Coal from tropical plants lies buried under icy lands because those places were once near the equator. The earth keeps records in layers of sediment, in the tilt of stone, in the magnetic particles frozen in cooling lava. These quiet messages, written over millions of years, tell the story of drifting continents and changing climates. And as the continents move, so too do the ecosystems they carry. Animals migrate, plants adapt, weather patterns shift. Australia, long isolated, became home to creatures unlike any other. Antarctica, now frozen and dry, once held forests and freshwater lakes. Africa and South America, now separated by a vast ocean, were once joined in a green, humid land. The Earth's crust is not just rock, it is a living stage on which evolution performs, guided by the slow rhythm of tectonic motion. Beneath all this lies the mantle, where rock flows like honey over centuries. This slow flow drives the plates above. Heat rises from the core, creating currents that move the solid rock. It's called mantle convection, and it is the engine behind plate tectonics. The Earth is not cooling evenly. Some parts release heat faster, some hold it longer. This imbalance, this gentle stirring, keeps the plates in motion. Like clouds carried by wind, the crust above rides the waves of deep time and temperature. Some scientists call this movement Earth's breath. Not the fast breath of lungs, but the breath of stone. Slow, steady, and enduring. Expansion and contraction. Rising and sinking. Breaking and healing. The Earth in its own way inhales and exhales over millions of years. And we, tiny and temporary as we are carried by that breath, across time, across distance, across the ever-changing shape of the world. The continents may one day drift together again. Scientists call it the next supercontinent, a new Pangaea that may form in another 200 million years. We will not be here to see it, but the Earth will continue its slow shaping, its patient rearrangement. The plates will keep moving, pulled by gravity, pushed by heat, guided by memory. And beneath it all, the mantle will stir and the core will glow, and the whispers beneath the crust will go on. Now let us return gently to the surface, carrying with us the long, slow breath of the earth. The whispers beneath the crust are still there, and steady, patient, and eternal. They do not rise with urgency, they do not roar for attention, but their touch is everywhere. In the shape of the land, in the curve of the coastlines, in the mountains that greet the sky, and the valleys that cradle rivers, you can feel the quiet motion that never sleeps. These movements, so slow that they escape our notice, have shaped the history of our world and continue to do so with every heartbeat of the planet. Every earthquake that shakes the ground is a reminder that the earth is alive beneath us. But not all its messages come with shaking. Sometimes the earth speaks in the lift of a hill, in the new flow of a spring, in the subtle tilt of a forest that was once flat. These signs, too, are born from the motion of plates, the bending, breaking, and healing of the crust over time. Like a tree growing slowly, its change is only visible when you look back across seasons. The Earth's surface transforms in ways we often overlook. But the record is there, written in stone. Consider the ocean floors where new crust is born. The longest mountain range on Earth lies not on land but deep beneath the sea, the mid-ocean ridge stretching through every ocean like the seam of a great blue quilt. Here the Earth breathes out new rock, creating fresh seafloor even now as you read these words. Tiny by tiny the ocean widens. The plates pull apart, magma rises and solidifies into basalt, dark, smooth and heavy. The crust at these ridges is among the youngest on Earth, while the crust that sinks into the mantle at subduction zones is the oldest, pulled back into the earth like a page turned in a book of stone. And above, on the continents, the motion continues. Africa is slowly splitting along the East African rift. Someday, in millions of years, a new ocean may form there. California edges north along the San Andreas Fault, changing shape and place across the ages. Australia drifts toward Asia. The Atlantic grows, the Pacific shrinks. These are not events of news or headlines. They are the soft turning of the planet's story, pages moving so slowly they feel still. Yet they are never truly at rest. This motion is not chaotic. It is part of the Earth's way of keeping balance, releasing pressure, recycling rock, distributing heat. When a plate sinks into the mantle, it does not disappear. It melts, reforms, and rises again elsewhere. The atoms in that rock may become part of a volcano or cool to form granite, or someday be ground into soil that feeds a tree. Even destruction, in the language of tectonics, is only the beginning of something new. The Earth teaches us that change, though slow, is the seed of renewal. We are visitors to this world in the briefest sense. Human lives are like the blink of an eye compared to the time of tectonic plates, but still, we are shaped by them. Cities rise on fault lines, cultures grow near mountains and rivers formed by plate movement. The places we call home were crafted by forces that began their work long before our ancestors walked the earth, and those forces will continue their quiet labour long after we are gone. To understand the Earth's motion is to step into a time scale far beyond our own, to feel the rhythm of eons, not years. But knowing this does not distance us from the Earth. It brings us closer. It reminds us that we are not separate from the planet, not standing on it like passengers on a train. We are part of it, born from its dust, shaped by its movement, destined to return to its soil. When we touch the ground, we touch the outer edge of a living system, a dynamic dance of rock and heat and time, and though we cannot feel the plates move beneath us, they carry us just the same, through ice ages and thaws, through the rising of seas and the carving of mountains. There is peace in this knowledge. The Earth moves, slowly and endlessly. It whispers in shifts and folds, in cracks and crests. It hums in ways we may never hear but always feel, deep down in the oldest part of ourselves, the part that still remembers what it is to belong to stone and sky. So the next time you stand in a valley or gaze up at a mountain, pause. Listen. The world beneath your feet is not still. It is breathing, it is becoming, and it will go on becoming in silence, in patience, in the long, soft turning that only the Earth knows how to do. There are places on Earth where the ground breathes fire, where the rocks glow like stars, and where entire mountains can rise overnight. These places are volcanoes, the Earth's way of speaking directly from its molten heart. But volcanoes are more than fire and ash. They are the breath of the planet, the exhale of deep pressure, the release of energy built up over millions of years. They do not simply destroy, they create, they renew, they write the landscape with fire. And though they seem fierce and wild, they follow rules written in stone and heat. Every eruption is part of an ancient cycle, the cycle of Earth shaping itself from the inside out. Beneath a volcano, miles below the surface, there is a chamber filled with molten rock. This rock, called magma, is born in the mantle, the soft, hot layer beneath the crust. Here, heat rises from the Earth's core, melting rock into a glowing, flowing liquid. When enough pressure builds, the magma looks for a path upward. Cracks and faults offer a way. The rock rises slowly, pushing against the crust. Sometimes it pauses in chambers, waiting, cooling slightly. Sometimes it pushes all the way to the surface, and when it does, it breaks through in an eruption, a release of light, sound, smoke, and stone. Not all eruptions are the same. Some volcanoes erupt gently, with lava flowing in slow rivers that light the night and harden into smooth dark plains. Others erupt violently, blasting ash and rock into the sky, shaking the ground for miles. It depends on the magma's ingredients, how thick it is, how much gas it holds, how deep it rises from. Thick, sticky magma traps gases. When the pressure becomes too much, the explosion is sudden and fierce. Thin magma lets the gas escape more easily, and so it flows instead of bursts. But whether slow or sudden, every eruption tells a story of the Earth's inner breath, rising, pressing, releasing. Volcanoes form in different ways. Some appear where tectonic plates collide. One plate sinks into the Earth, melts, and the magma rises to the surface. This is how the Andes and the Cascades were formed, chains of volcanoes tracing the lines where the crust moves. Other volcanoes form where plates pull apart, like in Iceland, where the Earth stretches and magma spills out into the gap. And some volcanoes form in the middle of plates over hotspots, places where heat rises from deep inside the Earth like a focused beam. The Hawaiian Islands are built from such a hotspot, each island a step in the path of drifting crust above a fixed plume of fire. Despite their danger, volcanoes are not just destroyers, they are builders. The very land they create becomes home to forests, rivers, and life. The soil around volcanoes is often rich and fertile, filled with minerals from deep within the earth. That is why people have lived near volcanoes for thousands of years, drawn by the promise of food and beauty, even with the risk of fire. Ancient cities grew beside them. Farmers worked their slopes. Temples were built in their shadows. And when the volcano spoke again, people listened, sometimes too late, sometimes just in time. The eruption of Mount Vesuvius in 79 AD buried the Roman city of Pompeii under ash, preserving it like a memory in stone. When modern archaeologists uncovered it, they found streets, homes, even food still sitting on tables. The volcano in its fury had frozen a moment in time. In Indonesia, Krakatoa's eruption in 1883 changed the sky around the world, its ash colouring sunsets for years. In Iceland, eruptions reshaped the land so often that new islands have been born from the sea. And in Hawaii, the slow flow of lava adds new earth, foot by foot to the edge of the ocean. To watch a volcano is to witness the earth alive. You can see the glow of magma in the night, hear the deep rumble of pressure rising, feel the heat and ash in the wind. It is as if the earth itself were breathing out centuries of memory. And even in silence, a sleeping volcano is not truly still. Deep below, magma stirs. The crust swells and shifts. Gases rise. Scientists watch carefully, measuring tiny quakes, checking the tilt of the land, listening for signs. They use satellites and sensors, trying to hear the Earth's whisper before it becomes a roar. But volcanoes are not simply threats to be feared. They are part of the Earth's great balance. Without them, much of the planet's surface would not exist. Islands would never have risen from the sea. Mountains would not have formed. The carbon dioxide they release helps keep the Earth warm enough for life. Their ash carries nutrients across oceans, feeding the smallest creatures and in turn the largest. They remind us that even in the planet's most violent acts, there is purpose, there is beauty, there is creation. So the next time you see an image of a volcano, its peaks smoking, its slopes glowing with molten light, remember that you are looking into the breath of the world. A volcano is not just a hole in the earth, it is a doorway to its heart, a reminder that beneath the stillness we know, there is movement, heat, and life waiting to rise. Let's walk deeper now, into the warmth and wonder that lives inside volcanoes. These mountains of fire are not just places where magma meets sky. They are the bridges between the deep earth and the surface, between past and future, between destruction and renewal. They may seem wild and unpredictable, but each one is part of an ancient pattern, a slow breathing rhythm that stretches back to the earliest days of the earth. Before trees, before fish, before the moon had fully settled into its orbit, volcanoes were already sculpting the world. Their breath shaped the first landmasses, formed the earliest skies, and perhaps gave rise to the chemistry of life itself. Inside a volcano, the story begins with magma. But this magma is not all the same. Some rise from great depths, from the mantle, where the heat is old and fierce. Others come from shallower sources, where rock has melted more recently, recycled from the crust that once was land, now softened and drawn downward. The chemistry of this magma decides everything: how it flows, how it erupts, what kind of land it builds. Some magma is rich in silica, thick like honey and prone to explosive bursts. Others are fluid, low in silica, and spread in broad glowing sheets. From these differences arise the many faces of volcanoes: the steep cone-shaped stratovolcanoes, the wide flat shield volcanoes, the gentle domes, and the mysterious calderas. Stratovolcanoes are perhaps the most iconic, towering, dramatic, often snow-capped and dangerous. They are built by layers of lava and ash, stacking like pages in a book written in fire. Mount Fuji in Japan, Mount St. Helens in the United States, and Mount Etna in Italy are all examples. They erupt with violence, sending plumes of ash into the stratosphere, sometimes changing the climate for months. The ash can circle the earth, cooling the sky, dimming the sun, yet from this ash comes fertile soil, and from that soil life begins again. Shield volcanoes like those in Hawaii tell a gentler story. Their lava is thin and fast, flowing in long, quiet rivers that harden into smooth black stone. These eruptions are slow and steady, painting the land with new rock, extending coastlines, creating fresh space for forests to grow. Mauna Loa, one of the largest volcanoes in the world, is a shield volcano. From its base on the seafloor to its summit, it rises taller than Mount Everest, and yet it does not shout. It flows softly and continuously, like a poem being written in heat. Then there are calderas, great bowls left behind when a volcano erupts so completely that the ground above collapses. Crater Lake in Oregon sits in such a caldera, its deep blue waters filling the hollow left behind by a vanished peak. Yellowstone, too, is a caldera, sleeping now but once capable of vast, world-shaking eruptions. These silent craters hold memory like a still lake holds the sky, reflecting what once was and quietly waiting for what may come. Volcanoes also live in the deep sea. Along the ocean floor, thousands of underwater volcanoes called seamounts rise in the dark. Some break the surface to become islands. Others stay hidden, forming ridges and chains beneath the waves. These undersea eruptions feed entire ecosystems, creating oases of life in the cold, empty deep. Around hydrothermal vents where volcanic heat escapes through cracks, strange creatures thrive: blind crabs, glowing worms, giant tube-like beings that feed not on sunlight, but on chemicals from the earth. Here, life blooms in the absence of light, proof that warmth and nutrients can give rise to wonder even in the darkest places. And perhaps in the very beginning life began here, in these volcanic places. Scientists believe that early Earth was too harsh for surface life, too hot, too battered by meteors. But deep underwater, near these vents, chemistry and heat might have come together to form the first building blocks of life. Tiny bubbles in warm rock charged by volcanic energy could have cradled the first strands of molecules that would one day become cells, then creatures, then us. If this is true, then volcanoes are not just creators of land, they are ancestors of life. Today, volcanoes still shape our world in quiet ways. They regulate the Earth's temperature by releasing gases like carbon dioxide, a necessary ingredient for keeping the planet warm. They cycle minerals from deep within the Earth to the surface, feeding the soil, the plants, the animals. Their eruptions can be tragic, but their absence would be even more so. A world without volcanoes would be static, cold and lifeless. Their fire keeps the planet breathing. And still they teach us humility. Even with satellites and sensors, we cannot always predict when a volcano will erupt. Some sleep for hundreds of years before waking. Others rumble without release. Scientists listen closely in measuring gases, watching the shape of the land, listening for tremors, but the Earth speaks in riddles. Volcanoes remind us that not all truths are ours to command. Some must simply be respected. In every culture, volcanoes hold power, seen as gods, spirits, sacred guardians. In Hawaii, Pele is the goddess of volcanoes, shaping the islands with her fire. In Japan, Mount Fuji is honored with shrines and stories. In Indonesia, mountains are revered, their slopes visited with offerings and prayers. These traditions do not come from fear, but from awe, an understanding that the earth is alive and that its fire, though hidden, touches all that we know. Let us now walk gently to the quiet edge of this story, where the fire begins to dim and the smoke fades into memory. The volcano, whether sleeping or awake, is never truly silent. Even in stillness, its heat lingers beneath the ground. Its breath curls softly through the soil, and its presence remains etched into the land. It is easy to think of volcanoes only in moments, eruptions, explosions, disasters, but their true story is much longer, written in the slow language of creation and change. Volcanoes are not interruptions in the Earth's peace. They are the Earth's voice, speaking in heat and stone, reminding us that beneath the surface of calm, there is always motion. When a volcano has erupted and its lava has cooled, the work is not finished. What remains is a raw, black landscape, sharp, cracked and strange. But time moves gently and nature follows. Wind brings seeds, rain falls into cracks, sun warms the stone. Slowly life returns. Mosses are the first, soft green cushions spreading across the rough lava. Then ferns, then trees. In places like Iceland and Hawaii, scientists have watched this process, tracing how forests are born from fire. It is called primary succession, when life begins in a place where there was none, a beginning from nothing, a story rising from ash. In this way, volcanoes teach us something beautiful, that endings can be beginnings, that destruction can be the seed of life. The land shaped by volcanoes is some of the most fertile in the world. The minerals in volcanic ash enrich the soil, helping crops grow strong and lush. Around Mount Vesuvius, vineyards and orchards thrive. On Java and Bali, rice fields ripple like green silk, fed by ash-fed soil and warm rain. Even after great eruptions, people return, they rebuild, replant, remember. It is not defiance, it is a quiet trust in the Earth's ability to renew itself. Volcanoes also shape more than land, they shape water. Some eruptions create lakes, where calderas fill with rain and snow. These crater lakes are deep and clear, their surfaces calm, their origins fiery. Crater Lake in Oregon is one such place, born from a mountain that exploded and vanished, leaving behind a still sapphire basin. Other volcanic lakes are hot, fed by geothermal springs, their waters bubbling with the breath of the earth. In places like New Zealand and Kenya, people bathe in these warm waters, feeling the warmth of magma far below, held safely in pools under the sky. Even the air is touched by volcanoes. The gases they release, carbon dioxide, sulfur dioxide, water vapor, rise into the atmosphere, sometimes cooling the earth, sometimes warming it. After a large eruption, sunsets can glow redder, skies can appear hazier, and global temperatures can dip for months or years. In 1815, the eruption of Mount Tambora in Indonesia led to the Year Without a Summer, a time when crops failed, snow fell in June, and skies stayed grey. Yet from that strange year came new stories, new art, even the birth of novels like Frankenstein, imagined during the cold, dark summer nights. Even in distance, volcanoes inspire, and so they continue, shaping the land, touching the sky, whispering beneath the sea. Some sleep for thousands of years, others erupt often. Some change shape quietly, building domes and cones. Others collapse, leaving behind wide valleys or hidden magma chambers. But always, they are part of the Earth's breath, slow, powerful, and steady. They are the places where deep time becomes visible, where you can stand on rock that was once liquid fire, where you can feel the warmth of the planet's core beneath your feet, even on the coldest morning. For those who live near them, volcanoes are more than landmarks. They are neighbours, ancestors, reminders. Children grow up watching steam rise from snowy peaks. Elders tell stories of the last great eruption. Farmers learn which slopes grow the sweetest fruit. And when the ground rumbles, when the birds fall silent, when the wind changes and the sky darkens, people listen. Not in fear alone, but in respect, knowing that the earth is speaking again, not in anger, but in rhythm. Volcanoes show us how the earth moves, not just with tremors, but with intention. They bring what is buried into the light. They break the surface to reveal what lies beneath. In doing so, they remind us of ourselves. We too hold pressure inside. We too have moments of eruption, of renewal, of beginning again. And like the earth, we are shaped by what burns within. As this story comes to a close, let us carry with us the warmth of the volcano, not as fear, but as awe. Let us remember that even in silence the earth is alive. Beneath the grass, beneath the pavement, beneath the sea, there is always motion. There is always breath. There is always the slow, glowing memory of fire, waiting to rise again, not to destroy, but to shape, to remind, to begin. Beneath every mountain lies a memory of heat. The rocks we see today, towering cliffs, folded ranges, smooth valleys, all began their journey not in silence but in fire. Deep within the earth, where pressure presses down like the weight of 1,000 oceans, minerals melt, shift and harden again into new shapes. This is where the story of glowing rocks begins, not in the cool touch of stone underfoot, but in the shimmering cradle of Earth's deep interior. The glow in the rocks may not always shine to the human eye, but it is there, in the warmth they hold, in the crystals they carry, in the energy they release when touched by time and pressure. All rocks have a past, and many were once liquid. Magma, the molten rock beneath Earth's surface, cools slowly as it rises. When it reaches the crust and begins to harden, it forms igneous rocks, the birthstones of the planet. Some of these, like granite, cool slowly underground, forming large visible crystals that glitter when held to the light. Others, like basalt or obsidian, cool quickly at the surface, their texture smooth, their secrets hidden inside. In each, there remains a memory of motion, of change, of heat now frozen into shape. Sometimes rocks are pressed and squeezed over millions of years, caught between the movement of tectonic plates. They do not break, they bend, they flow, almost like wax under steady hands. These are metamorphic rocks, born not from melting but from transformation. Slate was once shale, marble was once limestone. The heat and pressure don't erase the past, they reshape it. And in doing so they preserve whispers of ancient oceans, of forests turned to stone, of creatures long vanished. A glowing memory held in every layer. And then there are sedimentary rocks, the gentle historians. These are formed not from heat, but from layering, tiny particles carried by wind, by water, by gravity, settling one on top of the other. Over time, these layers compress, harden, and become pages in a stone book. They tell stories of rivers that flowed, of deserts that shifted, of seas that once covered the land. Fossils hide in these rocks, preserved in fine detail, leaves, shells, bones, all glowing with the light of a world that once was. But some rocks truly glow. Deep below, radioactive elements like uranium and thorium decay slowly, releasing energy in the form of heat. This heat, invisible and patient, warms the crust from within. It drives the movement of tectonic plates. It fuels geothermal springs. It helps shape volcanoes and rift zones. The rocks carrying these elements may seem ordinary, but inside they hum with a slow energy, a fire that cannot be seen, only felt across centuries. Other rocks shine in different ways. In caves, minerals like calcite and aragonite form crystals, lit by even the faintest touch of light. Some glow under ultraviolet rays, bursting into sudden colour, greens, oranges, purples, like fireworks frozen in time. Fluorite, for instance, gleams with blues and pinks under black light. These rocks carry not just the memory of heat, but the surprise of hidden beauty. Their glow is a kind of quiet celebration, a reminder that even the Earth's hardest faces can shimmer with light. The formation of crystals is a patient craft. As magma cools or minerals dissolve in water, atoms line up in perfect patterns, repeating over and over until a shape appears, a cube, a prism, a point. These structures are not random. They reflect the deep laws of nature, the hidden mathematics of heat and time. In quartz, in diamond, in garnet, the glow is not just in colour, but in order, a symmetry born from slow creation. And when we hold a crystal, we hold a fragment of that long process, a still echo of something once alive with motion. In some places, glowing rocks speak louder. Near volcanic vents, sulfur crystals gleam yellow in rising steam. Around hot springs, travertine forms rainbow terraces. In deserts, iron-rich stones shimmer red at sunset. These colours are not decoration. They are the fingerprints of heat and chemistry. Each hue tells a story. Each glow is a signal from the deep. And though we may pass them by to the earth, they are reminders of what it has survived and what it has built. Even the rocks that build our homes, our roads, our statues, carry this story. The marble of ancient temples, the granite of towering dams, the limestone of city blocks. Each stone once rested in fire or water or the crush of shifting plates. Each has waited, transformed and arrived. Their stillness is not absence, it is strength gathered over ages. Their weight is not burden, it is memory carried in silence. So the next time you pick up a stone, feel its warmth. Not just the warmth of the sun on its surface, but the deeper warmth it remembers. The glow in rocks is not just in how they shine, but in what they hold, stories of time, of pressure, of light trapped and released again in ways we are still learning to understand. These rocks, once molten and flowing, now quiet and still, are the Earth's slow language. And if you listen with your fingers, you might hear the soft hum of creation still pulsing inside. Now let's drift deeper into the hidden light of stone, where the Earth writes its oldest poems. Every glowing rock is a story held in stillness. Its radiance is not loud, but it lingers, in the warmth of a boulder on a summer evening, in the sparkle of a crystal under the forest floor, in the golden veins of quartz threading through a mountain's heart. This light does not flash like fire. It hums, quiet and steady, born from pressure shaped by heat and carried through time without haste. Even in their silence, rocks remain alive, not in the way we breathe, but in the way they record the world, holding echoes of ancient forces in every mineral, in every layer, in every glow. When we see a mountain glowing orange at sunrise, we are not only seeing light, we are witnessing reflection. The stone does not create light, it gives it back. But within some rocks, there is more than reflection. There is radiation, not dangerous in every case, but natural, gentle, and constant. This energy, released from decaying atoms deep within, is one of the Earth's oldest fires. Long ago, before any tree stood or bird flew, radioactive minerals began to warm the planet from within. This heat seeps through the crust, rising quietly, spreading like invisible breath through layers of rock. It helps to keep the mantle soft, the plates in motion, the volcanoes alive. And in that slow warmth life was sheltered, and change began. Glowing rocks can also help us keep time. Inside many of them are tiny crystals that contain secrets, traces of radioactive elements like uranium or potassium that decay at known rates. By measuring what remains, scientists can tell how old the rock is, sometimes down to the very millionth year. This process is called radiometric dating, and it is one of the ways we learn the age of the Earth. From these glowing clocks, we know the Earth is over 4.5 billion years old. We know when the first oceans formed, when the continents split, when the oldest fossils were laid into stone. The rocks do not speak, but they do count, slow, sure, and faithful to the rhythm of time. Some of the most magical glows come from minerals with fluorescence, a quiet kind of light that only appears under special conditions. Fluorite, calcite, willemite and scheelite are among them. Under ultraviolet light, they glow with blues, greens, even bright pinks. In the daytime, they appear plain, but under the right light, their secret is revealed. A gentle reminder that not all beauty is visible at first glance. These rocks are like memories that only show themselves when you know how to look. And in their glow is a metaphor. There is always more beneath the surface. Other rocks glow from within because of the way they were formed. When lava cools quickly, without time to crystallize, it can trap gases and minerals in glass-like textures. Obsidian is one such rock, dark, smooth and shiny like frozen midnight. In certain light it reflects with a shimmer, almost as if it remembers its days as liquid fire. Within obsidian, bands of light called sheen or rainbow luster can form, delicate flashes of colour caused by layers of tiny crystals or bubbles. This is the ghost of motion, caught in stone. When you turn the rock slowly in your hand, the colours move like a whisper, light that flickers softly from a still surface, and even meteorites, rocks that fall from the sky, carry glow. Some contain pieces of metal that sparkle in sunlight. Others hold rare minerals not found on Earth. These stones come from ancient collisions, broken moons, shattered planets. Their journey is long, and their glow is faint, but it carries the story of other worlds, a reminder that stone is not just of Earth, but of space. These glowing travellers bring with them stardust and silence, evidence of the fire that burns beyond our sky. And then there are the rocks that glow from within when they are broken, a phenomenon called triboluminescence. It happens in some quartz and sugar-like crystals, a quick silent flash of light when the rock is crushed or cracked. This glow is not caused by heat or radiation, but by sudden release of mechanical energy. It is brief, almost hidden, but it shows that even stillness can surprise us with light, that even pressure, released at just the right moment, can become brilliance. In the caves of Earth, far from the sun, glowing rocks light the way for creatures who know how to find them. Bioluminescent fungi sometimes grow on minerals. In New Zealand and the parts of Asia, caves sparkle with glowworms, tiny animals whose light reflects off damp stone, making walls seem like a starlit sky. The minerals themselves do not glow here, but they become mirrors for living light, a quiet partnership between biology and geology, between the breath of life and the patience of stone. These glowing places are sacred to many. Indigenous cultures around the world have stories about glowing stones, gifts from the Keres spirits in the mountain, eyes of ancestors. In their myths, light in the rock is a sign of presence, of protection, of deep connection to the earth. In temples and tombs, humans have placed glowing minerals alongside the dead, perhaps to light the way to other worlds. In cathedrals, stained glass is made from crushed stones, their powdered glow melted into colour. In jewellery, we wear the shine of ancient fires, not only as decoration, but as remembrance. And so the glow in rocks is not just scientific, it is emotional, it is poetic, it is the Earth's way of keeping its light even in darkness, of telling us that something bright still pulses within what seems quiet and cold. It invites us to wonder, to listen, to remember that not all fire burns in open flame. Some of it waits, glowing, patient, soft beneath the surface, like hope, like memory, like the earth itself. Now let us slowly return to the surface, carrying with us the quiet light we found deep in stone. The glow in rocks is not just a property of minerals, it is a reminder that the earth holds memories more patiently than we ever could, that time leaves marks not only in books or bones, but in the silent pages of crystal layer and pressure. When we touch a glowing rock, we touch something shaped by warmth, held by time, and revealed only in stillness. Its radiance does not rush. It does not demand to be seen. It waits quietly for light or heat or movement to set it free. On the surface, rocks seem so permanent. They do not wilt like flowers. They do not drift like clouds. They stay, lining paths, anchoring cliffs, pressing against the roots of trees. But this stillness is only an illusion of the short moment we live within. Every rock is in motion, if you stretch your vision far enough. Mountains rise and crumble, river stones are smoothed by flowing water, crystals dissolve and reform, shifting their shape with the seasons. Even now, deep within the earth, old rock melts, while new rock cools and hardens. The cycle never ends, just as the glow never fades, only moves. In some places, entire landscapes glow. Deserts, rich in iron, burn orange under the setting sun. Glaciers with rock trapped in blue ice gleam like glass. Cliffs of granite shimmer silver after rain. Caves glitter with mineral veins, thin as threads, bright as stars. These moments are easy to miss. A flash of colour on a canyon wall, a glint in the gravel beneath your shoe, a sparkle where the riverbed has worn through the surface. But if you stop, if you look closely, the earth reveals them. Its quiet flashes of memory, its light left behind by ancient heat. Even the paths we build are lit by stone, the marble steps of museums, the polished floors of libraries, the carved faces of statues worn smooth by rain. These rocks were once buried deep, shaped by the earth's quiet fire, then brought to light by human hands. We do not always remember this when we walk across them, but they remember. Their weight, their shine, their coolness in our palms, all of it is a message passed through ages. You are holding something older than the mountains, something that once flowed like water, glowed like ember, rested in darkness before rising to the day. And sometimes the earth itself gives us back light in unexpected ways. After certain earthquakes, rocks under stress can emit faint flashes of light. These are called earthquake lights, brief ghostly glows seen before or during seismic events. No one fully understands how they happen. Perhaps it is friction or electric charge or gas released through faults, but whatever the cause, they are another way the earth reveals its buried energy, even if only for a heartbeat. A flicker in the sky, a glow from the cracks, a whisper from below. We also carry glowing rocks with us into space. On the moon, astronauts found basalt, dark volcanic stone formed long ago when the moon itself had a molten heart. On Mars, rovers have studied hematite, a mineral that forms in the presence of water. Meteorites, when split open, reveal grains of olivine that shine like tiny green stars. Even in the silence of space, the glow of stone remains, born of pressure, of heat, of ancient collisions that shaped entire worlds. And inside our own homes, glowing rocks keep watch. Salt lamps, made from crystals of halite, shine softly in bedrooms. Geodes cracked open on shelves reveal glittering quartz. Jewellery holds agate, opal, amethyst, stones that once slept in the dark, now worn as emblems of beauty, memory, and quiet power. Some believe they carry meaning, that rose quartz holds love, that obsidian shields from harm, that citrine brings joy. Whether true or not, the stories we wrap around glowing stones are old, rooted in the same awe that first stirred when early humans found light in rock. In the end, the glow in rocks is not only in their shine, but in their stillness. They remind us that light does not always have to be loud, that change can happen slowly, quietly, under pressure, that something beautiful can emerge not in an instant, but after 1,000 years. They teach us to listen for the long story, to look beyond the surface, to wait for the moment when the hidden spark is revealed. So the next time you hold a pebble, or walk across a stone path, or glance at a crystal in sunlight, remember what lies within. Not just minerals, not just colour, but a piece of Earth's breath held still. A message from the deep still glowing, still speaking, still becoming light. Time does not only move forward. Sometimes it moves downward, so buried in layers of stone, trapped in bubbles of amber, written in the patterns of ancient rocks. This is the story of deep time, told in the language of heat and stone, in places where the past still burns. Beneath your feet, the earth holds memories not just of years or centuries, but of ages, of landscapes that vanished before the first bird flew, of oceans that dried before any eye could watch them go. In these hidden places, deep below the crust, time glows, not as light, but as warmth. This heat, slow and enduring, is what fuels the hidden engine of our world. And the rocks that hold it are more than just old, they are guardians of time itself. The Earth's interior is not empty or hollow. It is full, dense, layered, alive with motion. At its very centre lies the solid inner core, surrounded by a swirling sea of molten iron. This is wrapped in the mantle, thick rock that moves like slow caramel, and above it, the crust, thin and cracked like the shell of an egg. The deeper you go, the hotter it becomes. This heat is left over from the Earth's birth, from collisions of ancient planetesimals, from the squeezing of gravity, and from the silent decay of radioactive elements that continue to whisper warmth into the planet's bones. When rocks are buried deep enough, they change. They forget their old shapes. Pressure crushes them. Heat softens them. Atoms rearrange. New minerals form. A piece of sandstone becomes quartzite. Shale becomes slate. Limestone becomes marble. These are not just new names, they are new beings. Each change is a step on the path of metamorphism, where rock does not melt, but becomes something else entirely. And within every band, every shimmer, every polished face of these stones lies a memory of the journey, of how deep it once rested, how hot it once became. We measure time in years, but the Earth does not count like we do. A rock buried 1 mile deep might take 100 million years to rise again to the surface. An ocean basin might last 500 million years before it closes. A single mountain range might grow for 70 million years, then erode over another 100. These are spans beyond memory, beyond human history. But the rocks remember. In their folds, in their layers, in the crystals they hide, they record the pressure of the past. Every ripple in a metamorphic rock is a wrinkle in time, a moment when the Earth bent, twisted, or stretched. There are stones so ancient they hold the light of a young planet. Zircon crystals, found in Australia, are over 4.3 billion years old, nearly as old as Earth itself. Inside these tiny gems are bubbles of information, how hot the world once was, when the first oceans formed, when the crust began to cool. Scientists use them like tiny time machines, studying their chemical makeup to learn about the conditions of early Earth. Each crystal, no bigger than a grain of sand, is a witness to a time when no eye saw, no foot stepped, no voice spoke. The heat deep within the Earth rises slowly, feeding systems we see at the surface. It warms underground aquifers, creating hot springs. It melts rock into magma, forming volcanoes. It drives the flow of the mantle, which moves the tectonic plates. But it also does quieter work. It bakes rocks in place. It cooks carbon into diamonds. It turns organic matter into oil and gas, storing the breath of ancient forests in pockets beneath deserts and seas. These transformations happen slowly, measured in millions of years, not minutes. The warmth of deep time is patient but powerful. And sometimes this heat tries to escape. It rises through faults, through fractures, through vents in the crust. In places like Iceland, Yellowstone, and New Zealand, you can see the breath of deep time in geysers, steam, and boiling pools. These geothermal areas are not just tourist wonders, they are windows into the Earth's warmth. They let us glimpse the silent fire that continues to burn beneath continents and oceans. And when harnessed gently, this heat can be used to warm homes, to turn turbines, to offer light from the very bones of the Earth. The rocks born in deep time do not always rise quickly. Some are pushed up by the slow lift of mountains. Others wait for erosion to uncover them, grain by grain. And when they do reach the light, they carry with them stories few others can tell. Walk through the ancient rocks of a canyon, and you are walking through time. Each layer is older than the one above it. The deeper you go, the farther back you travel, not in imagination, but in stone. Here are fossils from the age of fish. There are sandstones from vanished deserts. And below that, twisted metamorphic rock from a time before complex life even stirred. To hold such a rock in your hand is to hold more than matter. It is to hold memory, not just of heat and pressure, but of silence. The silence of deep time is vast. It is not empty, but full of waiting, of motion too slow for eyes, of stories too long for words. And yet in every glowing mineral, in every heat-born fold, the story remains, waiting to be touched, waiting to be seen, waiting to be remembered. Let's follow that heat deeper now, as if sinking through layers of stone and history into the furnace where deep time stirs. Down here, beneath the surface we walk on, is a world without sunlight, but not without light. The glow comes not from the sky, but from within the Earth itself. It is not a light you can see, but a warmth that never fades. A warmth born from ancient collisions, from the slow squeeze of gravity, from atoms breaking down over eons. It is a warmth that pulses through rock like a quiet heartbeat, steady, invisible, constant. This deep heat changes everything it touches. Rocks are not fixed things, even if they seem still. Under pressure and time, they shift, flow, bend. They soften, recrystallize, become new, and in this slow transformation, they carry the memory of the depths. A piece of limestone formed from coral in a shallow sea may find itself buried, pressed by miles of rock above it, heated until it becomes marble, white, gleaming, smooth. When we carve that marble into statues or buildings, we are working with something that once belonged to the sea, then to the fire, and now to us. This journey of stone is not a straight line. It moves in cycles, what scientists call the rock cycle. A volcanic rock like basalt can be weathered into sand, compacted into sandstone, buried and heated into quartzite, then melted and erupted again. Each transformation takes thousands, sometimes millions of years, and in each phase the rock glows in its own way, sometimes with visible shimmer, sometimes only in the way it tells its story to those who know how to read it. A geologist can look at a crystal and see its past. A paleontologist can hold a fossil and imagine the ocean that once covered that place. The Earth writes slowly, but it writes clearly, and in minerals, in heat, in the deep pressure of time. Beneath the crust, in the upper mantle, heat flows not as fire, but as motion. Rock here is not fully solid nor truly liquid. It moves like thick dough, rolling and stretching under heat's quiet command. This movement carries heat upward, like the rising of smoke from a fire that never goes out. It's called convection, and it's the same principle that makes soup swirl in a pot. The Earth stirs itself slowly from the inside, this mantle flow gently pushing the plates above it, cracking them apart, colliding them together, making mountains, rifting continents, and opening oceans. All of this begins in the unseen glow of the deep. There are places where we see this heat directly, volcanoes of course, but also deep mines and boreholes. In South Africa, mines reach nearly 4 kilometers down, and the temperature in those tunnels can reach over 55 degrees Celsius. In Iceland and Kenya, boreholes drilled for geothermal energy find rocks so hot that steam rises instantly. The deeper we go, the hotter it gets. This gradient, called the geothermal gradient, varies from place to place, but always it rises. The glow of deep time waits just beneath the surface, closer than we imagine. Some of the oldest rocks ever found are hidden deep within mountain roots. In Canada's Hudson Bay region, rocks over 4 billion years old have been discovered, remnants of the earliest crust. These rocks bear witness to a time when the Earth's surface was still forming, when the planet was bombarded by space debris, when the oceans were just beginning to collect. And even they were not the first. Beneath them lie minerals formed from even earlier molten layers, now locked into place, their stories encoded in the way atoms are arranged, the trace elements they contain, the isotopes they preserve. Even diamonds, symbols of clarity and beauty, are born from this depth. They form in the mantle over 100 kilometers below the surface, under crushing pressure and high heat. Carbon atoms arrange themselves into the tightest possible lattice, and over millions of years these crystals are pushed upward through volcanic pipes. When we hold a diamond, we hold a piece of the deep earth, a piece of carbon that once felt the full embrace of time and fire. It is light born from darkness, pressed into brilliance. Yet not all heat escapes. Some remains locked away. In granite bodies and deep continental roots, radioactive elements like uranium, thorium, and potassium continue to decay, producing steady heat. This radiogenic warmth accounts for nearly half of the Earth's internal temperature. It is like a candle that never burns out, glowing not with flame, but with the steady hum of atomic change. We cannot see it, but we feel its effects, in the rise of land, the drift of continents, the trembling of ground, the warmth of deep water that feeds life on the cold seafloor. These hidden systems also help create resources. The heat and pressure transform organic material into coal, oil, and gas, the stored sunlight of ancient forests and plankton. They also concentrate metals, copper, gold, silver, in veins that miners seek deep underground. These treasures are not just wealth, they are records. They tell us where the heat has moved, where water has flowed, where the earth has changed itself from within. And so the deep earth is not a place of chance, it is a place of making, a place of slow alchemy. The heat that glows in its rocks shapes our mountains, fuels our volcanoes, drives our plates, and even warms our homes. It is the oldest part of our world and the most constant. And though we may never walk there, its influence is beneath our every step, rising in steam, flowing in rivers, glowing in stone. Now let us rise gently from the depths, bringing with us the glow of deep time, not as heat on our hands, but as a memory we carry in our bones. The warmth that hides in the earth's stone heart is not distant. It is the foundation of all we know. It shapes the land we walk, the air we breathe, the oceans that surround us. It is the quiet force that builds mountains, folds rock, stirs magma, and whispers through the steam of every hot spring. It moves slowly, invisibly, yet endlessly. It does not speak in words, but in warmth. It does not rush. It simply continues. The world we know is made possible because this heat never sleeps. Without it, the plates of the earth would not drift, continents would not collide, volcanoes would not rise, the sky might look the same, but the land beneath would be lifeless, still, and quiet in a way that feels less like peace and more like absence. The deep earth glows for a reason. It is the earth breathing from the inside out. It is motion that never ends. And in that motion, life has found a way to grow, to evolve, to begin again after every change. The oldest rocks, those ancient witnesses, rise to the surface only after eons. They come worn, reshaped, lifted by the mountain-building forces, and uncovered by wind, rain, and time. When we hold these rocks, when we touch a piece of the earth that is older than trees, older than animals, older than the moon's familiar face, we touch something that saw the planet before it was ready for life. We touch the heat of a world still forming, and though it has cooled, though it has turned to stone, the glow of that moment remains, soft and deep. Some rocks tell us this story not in their structure, but in the tiny fossils they carry. Stromatolites, layered structures made by early microbial life, are among the oldest evidence of biology on Earth. They formed in shallow seas more than 3.5 billion years ago, when the sky had no blue and the land was bare. And even these simple forms depended on the warmth of the planet, on geothermal heat that kept water liquid, on minerals stirred by deep flows, on energy that came not from the sun but from within. In modern times, we've learnt to listen more carefully to the deep earth. We use seismic waves to map the mantle, thermal sensors to track underground temperatures, isotopic studies to read the age of minerals. We've built models and machines that help us understand how the planet moves and changes from the inside. Yet with all this knowledge, the glow of deep time remains something we feel more than we can fully explain. It is steady. It is patient. It is beyond the ticking of clocks or the turning of calendars. It is a rhythm that outlasts cities and empires and even the memory of names. Geothermal energy, a gift from this inner warmth of Inpa, is now being harnessed more and more. It powers homes in Iceland, heats greenhouses in Kenya, provides clean, quiet electricity in many places. It is the breath of the earth made visible, made useful, made kind. And it reminds us that even as we build toward the future, we are still held by the oldest forces of all. In the warmth of a pipe, in the spin of a turbine, in the mist of a geyser, there is a line drawn straight back to the beginning. We walk atop these stories every day. A hill may be made of ancient seafloor, a cliff may be the frozen remains of lava. A stone wall may be built from once molten granite, carried from a mountain's roots. We do not always notice. But the earth does not ask for notice. It only continues, glowing, folding, rising, resting. It lets us live in the moments, while it moves through millennia. And when we stop, when we sit still enough to feel the heat in a smooth rock or see the shimmer in a cut face of marble, we join that slowness. We become part of it, even for a breath. Deep time is not something to fear. It is something to understand, to hold gently, to admire. It reminds us that life is fragile but also resilient, that heat, though hidden, can create, that pressure, though silent, can shape, and that in the places we cannot see, beneath our cities, beneath our oceans, beneath the quiet fields where children run, there is a world still forming, still glowing, still dreaming the shape of mountains not yet born. So when you next feel the warmth of the earth beneath your feet, imagine the fire beneath it. Imagine the rock still glowing in the dark, still changing, still remembering. Imagine the stories being written right now in silence deep below, and know that even though we live on the surface, our lives are lit, quietly always, by the gentle glow of deep time. Far above the clouds and yet born from deep within, there is something invisible wrapping around the earth, a soft shield, a quiet field, a guardian we cannot see but always feel. This is Earth's magnetic field, and it begins in one of the planet's most secret places, the molten outer core. It spins silently beneath our feet, a sea of liquid iron flowing around a solid heart, creating currents and loops of energy that stretch far beyond the atmosphere. This magnetic murmur is not a sound we can hear, but it shapes everything, from the way a compass needle points north, to the way birds find their path, to the way the sky dances with light in the cold north. Imagine, deep beneath the ground, a spinning layer of molten metal. This is the outer core, mostly iron, glowing and moving in wide, slow currents. As the Earth turns, this liquid iron turns with it, and in that turning it creates electricity. Not the kind that lights a bulb, but a powerful sweeping force that surrounds the planet. This is how our magnetic field is born. Not from machines, not from magic, but from motion. It is called the geodynamo, and it has been humming for billions of years. The field it creates stretches into space like a bubble. It's called the magnetosphere, and it deflects charged particles from the sun, high-energy winds that would strip our atmosphere if they were allowed to reach us directly. Without this magnetic field, Earth would be bare and lifeless like Mars, its air long blown away, but the field catches these particles, slows them down, and sends them gliding around the planet. Sometimes these particles sneak into the atmosphere near the poles, where the magnetic field lines curve down, and when they do, they meet the air and make it glow. These glows are the auroras, the northern and southern lights. Curtains of green, red, and purple ripple across the sky like breath turned into colour. They dance, shimmer, and flicker, their shapes following the invisible lines of the magnetic field. What we are seeing in those lights is a collision. The wind from a star meeting the breath of a planet and painting the sky with their quiet struggle. It is a reminder that we are part of something much larger than ourselves, something moving, turning, glowing beneath and above. But the magnetic field doesn't stay the same. It shifts, it wobbles, it grows stronger and weaker over time. Sometimes it even flips. North becomes south and south becomes north. This reversal doesn't happen suddenly. It takes thousands of years, and the field doesn't disappear during it. It just becomes more complicated. Right now, the field is slowly weakening in some areas, and scientists are watching carefully. We don't know when the next reversal will happen, but we know it will. The Earth has done it many times before, and while the field changes, life continues. Animals have learned to read this invisible map. Sea turtles cross oceans guided by it. Salmon return to their birthplace with its help. Birds migrate in part by sensing magnetic direction. Some scientists believe that even certain bacteria align themselves using the field. And though we can't feel it in our skin, we use it too. Every time we read a compass, every time we orient a satellite, every time we protect our electronics from solar storms, the magnetic murmur is always there, holding the shape of our world. Inside the rocks, the field leaves a record. When lava cools, the tiny magnetic minerals within align with the field like compass needles. Once solid, they keep that direction frozen in place. By reading these rocks, scientists can trace the history of the Earth's magnetism, every flip, every shift, every change in strength. These records, stored in layers of ocean floor and ancient volcanic cliffs, are like diary entries from the Earth itself. They show that the field has flipped hundreds of times, and that even in reversal, life adapted, survived, and flourished. So the next time you see a compass needle quiver, or hear about a solar flare brushing against our planet, remember the core. Remember the liquid iron turning in the deep, the silent dance of particles far above, the glowing curtain of auroras at the poles. The magnetic murmur is not just a shield, it is a song without sound, playing always, shaping the sky, guiding life, and holding the edge of space at bay. It is the quiet breath of a planet that never sleeps. Let's drift deeper now, into the movement and memory that create the magnetic murmur. The Earth's magnetic field is not just a shield, it is a pattern written in the invisible, drawn by molten metal flowing beneath continents and oceans. Inside the outer core, temperatures reach over 4,000 degrees Celsius. Yet the iron there does not glow in flames. It flows like a vast ocean of fire, always moving, always turning. These movements are not random. They create loops and swirls of electrical current, and from these currents, magnetism is born. It's a delicate, powerful engine, one that has worked quietly for billions of years. The inner core is solid, but the outer core moves around it. And as it moves, it creates the dynamo, a self-sustaining loop where motion creates magnetism, and magnetism influences motion. This process is complex, but the result is simple. A magnetic field that reaches far into space, strong enough to bend solar winds and carve a safe path for life. Without this core, there would be no compass pointing north, no shield against radiation, no calm skies above the poles. It is a reminder that something as small as the spin of atoms can shape the fate of a planet. But this field is not steady like a line. It pulses, it drifts, it breathes. The North Magnetic Pole, once near Canada, is now racing across the Arctic towards Siberia. It moves slowly but surely, driven by changes in the flow of molten metal below. Scientists map this movement, adjusting navigation systems year by year. The field itself, they've found, weakens and strengthens like a tide. Over the past 200 years, it has grown slightly weaker. This doesn't mean it's vanishing, only that it is shifting in the way the Earth always shifts, slowly, mysteriously. When a reversal begins, when the poles begin to swap, the field becomes tangled. Instead of a neat loop from south to north, it twists into patches, with small north poles forming and fading all over the globe. During this time, the magnetic shield weakens in places, and more cosmic particles reach the surface. Yet the Earth does not become unsafe. Life continues. The reversals take thousands of years, and the field never fully disappears. Fossils and rock records show no mass extinctions tied to these flips. Instead, life adapts. Birds and fish adjust. Creatures that use magnetism to navigate find other clues in the stars, in the ground, in the light. And there are even older records, hidden in the seafloor. As magma rises at mid-ocean ridges and hardens into new crust, the iron minerals inside align with the current magnetic field. Over time, as the field flips, stripes of opposite magnetism form on either side of the ridge. Perfect mirror images, stretching across entire ocean basins. These magnetic stripes are more than just patterns. They are a timeline, a barcode of Earth's history, helping scientists measure the speed of plate movement, track past reversals, and glimpse the memory of the core. Even trees hold a trace of this murmur. When cosmic particles reach Earth, they interact with the upper atmosphere, creating rare isotopes like carbon-14. These isotopes are absorbed by plants, and their levels fluctuate with the strength of the magnetic field. In tree rings, scientists have found clues to ancient solar storms and magnetic changes. Even living wood, it seems, listens quietly to the sky, to the sun, to the core below. And sometimes, when the sun erupts in massive flares or coronal mass ejections, these particles flood toward Earth in powerful waves. The magnetic field catches them like a net. It bends, it flexes, it stretches. The impact can cause magnetic storms, flickers in power grids, radio blackouts, sudden surges in electric lines. But it also makes the auroras blaze more brightly, turning the sky into a moving painting. In rare moments, the northern lights can be seen far from the poles, glowing even above city skylines, a sign that the magnetic murmur has been touched by a louder note from the sun. In space, satellites and astronauts rely on the field for protection. Outside the magnetosphere, radiation is stronger, more dangerous. The International Space Station, still within the protective shell, orbits safely. But astronauts travelling beyond, to the Moon or Mars, must be shielded carefully. The Earth's field, stretching like a cocoon into space, is one of the planet's greatest gifts. It allows life to thrive not just because of the warmth of the sun or the water of the oceans, but because of this invisible guardian, always humming, always moving, always shielding from the silence of space. And as we explore other planets, we look for their fields too. Mars once had a magnetic field, but it faded. Without it, the solar wind stripped away much of its atmosphere, leaving behind a cold, dry world. Venus spins too slowly to sustain a strong dynamo, and its atmosphere, though thick, is scorched by radiation. Only Earth, with its spinning iron heart, has maintained a field strong enough and steady enough to shelter life for billions of years. The magnetic murmur is not just a feature, it is a foundation. So even though we cannot see it, the field surrounds us, shaping our path, guiding our lives, humming in the background of every journey. We are beings of the surface, but we live within a sphere of influence much greater than the ground beneath our feet. It stretches far beyond the clouds, far beyond the sky, catching storms from the sun, painting auroras on the night, and whispering through iron-rich stone laid down in ancient seas. It is the quiet song of a living planet, sung in loops and fields and flows of energy, a lullaby that has never ceased. Let us now rise slowly from this ocean of invisible motion and stand once more on the ground beneath the sky, carrying the magnetic murmur with us. Though it cannot be seen or touched, it is always there, circling us, shielding us, shaping the world in ways so soft and quiet we forget to notice. And yet, From the tiny turning of particles in the core to the sweeping curtains of auroras above, this field speaks to the balance that holds the Earth in harmony. It is a balance of opposites, of north and south, of deep and high, of motion and silence. And it reminds us gently that some of the most powerful things in life are also the most unseen. We live on the surface, where gravity pulls us down and the sky seems still. But above us, the magnetic field arches like a great dome. It moves with the solar wind, shaped and stretched into a long tail that trails away from the sun. Within this tail, particles from the sun are caught and held, moving along magnetic lines like dancers following their invisible paths. Sometimes they slip into the atmosphere and touch the air, and when they do, they make it glow. The auroras are more than just a light show. They are the signature of a living world protecting itself. For those who live near the poles, the auroras are familiar, even comforting. In places like Alaska, Canada, Finland, and Siberia, people grow up under skies that ripple with colour. They watch as green waves pulse above snowy trees, as red bands flicker on quiet nights. Some cultures see these lights as spirits, others see them as messages, scientists see them as data, but all who witness them feel something, wonder, awe, a soft reminder that the world is more alive than it seems. The field speaks here not in words, but in motion, in colour, in gentle surprise. In ancient times, sailors learned to navigate by the stars and by the needle of the compass, a simple tool that listens to the Earth's magnetic whisper. That whisper, born deep in the molten core, guides metal with invisible threads. And even now, in a world filled with satellites and GPS, the compass still matters. In the forests, in the deserts, on oceans without signposts, that little red needle still points the way, not because of luck or magic, but because of the steady spinning of the Earth's heart far below. The magnetic field also moves through technology, though we rarely think of it. Every time we charge a phone or listen to music through a speaker or swipe a credit card, we are using principles tied to magnetism. Electricity and magnetism are sisters, linked by the same fundamental forces. A changing magnetic field can produce electricity, and electricity can create magnetism. This is how generators work. This is how motors turn. It's how the modern world moves. The core's murmur is echoed in our machines, in every hum, in every coil, in every circuit alive with motion. And still, it changes. Slowly. Softly. Scientists now map the field every year, tracking the shifting poles, the patches of weakness, the regions where the field grows stronger or fainter. There is an area over South America and the South Atlantic where the field is especially weak, called the South Atlantic Anomaly. Satellites passing over it sometimes malfunction, touched by the stronger radiation that slips through. It is not dangerous to us on the ground, but it is a signal, a reminder that the field is not fixed but fluid, that the Earth is still righting itself, even now. As we look to the future, we wonder what role this field will play in the stories still to come. Will it continue to protect us as we travel farther from home? Will we learn to mimic it, to build fields around spacecraft or distant worlds? Will we find echoes of it in the magnetic signatures of exoplanets? Clues that they too might hold molten hearts and moving metals, and perhaps even life? For now, we are still learning, still listening, still watching the sky for lights and the stone for memory. Every magnetic stripe on the ocean floor, every reversal marked in cooled lava, every quivering compass needle tells us the same thing, that we live within a living, turning, breathing planet. That its voice may be low, but it is always speaking. So tonight, if the sky is dark and clear, look north or south. Look where the magnetic lines curve into the earth. And if you're lucky, you might see them, the lights that dance when the sun meets the field. And even if you don't, know that above you and beneath you and around you, the magnetic murmur is still humming. It holds you gently, it guides you quietly, it shields you faithfully. It is the whisper of a world that never truly rests. Beneath rolling fields and quiet towns, beneath forests and highways and oceans, there are giants that sleep in stone. They do not breathe, but they move. They do not speak, but they reshape the earth. These sleeping giants are ancient fault lines, deep magma chambers, and buried cracks in the planet's crust, places where the earth has once roared and where it may one day rise again. They lie still for decades, centuries, even millennia, their presence forgotten by time and softened by the passing of generations. But silence does not mean stillness, and sleep in the language of the earth is often only a pause. These sleeping giants are the remnants of once powerful forces. A fault line that slipped in a great quake may not move again for 100 years, but it is still there, beneath your feet, holding tension like a breath held too long. A volcano that once blanketed the sky with ash may sit quietly for centuries, its peak softened by the wind and snow, its base green with trees. But inside, deep within the earth, magma still stirs. It shifts, it warms, it waits. This is the nature of the earth, to remember its past in layers of stone, to hold the potential of change even in moments of calm. Some of the greatest eruptions in Earth's history came not from towering mountains, but from calderas, wide sunken basins left behind by past collapses. Yellowstone in the United States is one such place. It looks peaceful, geysers, forests, clear blue springs, but below it lies a vast magma reservoir, stretching for kilometers. It has erupted catastrophically in the past, and though it sleeps now, scientists watch it closely, listening to the tremors beneath, measuring the ground's breath as it rises and falls like the chest of a sleeping creature. Other giants lie along subduction zones, the great meeting places where one tectonic plate dives beneath another. The Andes, the Himalayas, the Aleutian Islands, all are born from this deep and grinding movement. Earthquakes often mark their edges, sudden reminders that the crust is under strain. Yet between these events, the ground seems still. People build homes, cities, lives atop these quiet zones. Crops grow, roads stretch, but beneath the plates continue to press. They store energy like a spring being slowly wound tighter. And one day, with no warning, the tension may release. There are places on the ocean floor where cracks run deep, mid-ocean ridges, where magma rises and new crust forms. These underwater giants rarely draw attention, but they are always at work, reshaping the seafloor, guiding the drift of continents. Sometimes, when the pressure is too great, a fissure will open, and an earthquake will ripple across the sea. If it displaces enough water, it can send a tsunami rushing toward distant shores, a wave that began with a murmur in the deep, and yet these giants are not our enemies. They are part of Earth's breathing. Just as lungs expand and contract, so too does the planet stretch and compress. Just as hearts beat, so too do mountains rise and fall. The sleeping giants are not cruel or kind, they are simply the earth in motion. To understand them is not to fear them, but to respect their rhythms, to learn their signs, to live in harmony with their silence and their song. Scientists now use satellites and sensors to track these giants. They measure ground motion with lasers, monitor gas emissions from volcanoes, study patterns of microquakes, tiny shifts that hint at deeper stirring. These tools are like stethoscopes held to the planet's chest, trying to hear its heartbeat. Sometimes the signs are clear: a bulge in the earth, a swarm of small quakes, a rising plume of steam. Other times there is no warning. The ground moves, the sky darkens, and we remember how alive the earth truly is. But even in rest, the giants give. The soil around volcanoes is rich, feeding farms and forests. The hot springs and geysers bring warmth and water. The rift valleys become lakes, homes to fish and birds. The earthquakes remind engineers to build stronger, to listen better, to prepare with wisdom and care. These forces that can shake us also shape us. They remind us that stillness is not the same as safety, and that from the slow dance of the earth, both wonder and warning can rise. And so we live atop these giants, not above them, but with them. We plant gardens where lava once flowed. We build cities where plates once collided. We tell stories of the mountains and the quakes, the ash and the fire, the calm and the storm. We learn over time to listen to the quiet, and in that listening we begin to understand the giants are not gone. They are only sleeping, and even in sleep they shape the world. Let us now walk gently among the sleeping giants, listening not for their roars, but for the signs they leave behind, faint whispers in stone, subtle shifts in ground, tiny tremors that ripple through the deep like sighs beneath a still surface. These giants do not slumber without movement. Even in their silence they stir. They reshape the land grain by grain, unseen but not unfelt. The very ground we stand on is a record of their breath, a canvas where time and pressure draw the story of the earth's deep pulse. In places where giants have walked, the earth remembers. A folded hill may once have been a thrust from colliding plates. A broad valley might be the scar of a caldera long since cooled. The pattern of rivers and lakes often traces the faults beneath. Water follows the path of least resistance, and so too does memory. In places like the San Andreas Fault or the East African Rift, the Earth is not torn open but stretched inch by inch, year by year. The crust may move no faster than a fingernail grows, but over millions of years, that quiet tug creates new seas, splits continents, forms the spine of mountain ranges. The giants do not wake all at once. Sometimes they stretch in their sleep. Volcanoes, too, whisper while they rest. Beneath their peaceful summits, chambers of magma slowly fill and shift. Gases build, rise, and escape through vents. The ground may lift slightly, like a chest taking a breath. Seismometers pick up tiny earthquakes, not destructive but rhythmic, the sound of magma pushing against the Earth's resistance. In Iceland, Japan, Indonesia, and other volcanic belts, scientists watch for these patterns with reverent attention. One small signal might mean nothing, but together, over time, they can suggest a story. A deep stirring, a slow awakening, a possibility of change. In tectonic zones, it is not just the movement that matters, but the pause. Earthquakes often come after long periods of stillness, when the pressure between plates is built to a point where it can no longer be held. The crust slips, the energy releases, and the ground jumps. These earthquakes can last only seconds, but their impact reshapes lives. Buildings fall, rivers shift, islands rise, and beneath it all, the fault, the sleeping giant, settles once more, its tension eased for a time, its sonnets returned, its strength renewed. Yet not all signs are violent. Some are soft and luminous. Around dormant volcanoes, warm springs bubble to the surface, bringing with them minerals from deep below. In places like Yellowstone, New Zealand, and Kamchatka, these geothermal waters form terraces of white and orange, steaming gently in the morning light. The giants here speak in warmth. They offer shelter to rare species, create landscapes unlike any other. The colours in these springs are born of bacteria that thrive in extreme heat, tiny life forms that remind us even in the Earth's fire, life finds a way to glow. Scientists now use a combination of tools to listen to the giants. GPS stations measure how much the ground shifts, tilt meters detect subtle changes in slope, satellite radar images track ground inflation. Thermal cameras spot areas of unusual warmth. Gas sensors sniff the air for sulfur, carbon dioxide, and other volcanic exhalations. And seismic networks form webs beneath the Earth, catching every tremble, every shift, every crackle. These technologies don't stop the giants from waking, nothing can, but they help us understand the rhythm of their rest. Understanding these rhythms has saved lives. In 1991, scientists studying Mount Pinatubo in the Philippines noticed an increase in gas emissions and earthquakes. Their warnings led to a massive evacuation just before the volcano erupted. Though the eruption was vast, one of the largest of the century, many lives were spared because someone listened to the quiet and read the signs. In Chile, in Japan, in Italy, around the Ring of Fire and along every fault line, this is the lesson. Not to control the giants, but to understand their breath. In some places, ancient people mark the presence of sleeping giants in stories and stones. Indigenous communities told of mountains that breathed fire, rivers that ran backward, stars that fell when the ground shook. Petroglyphs show eruptions and tsunamis carved into rock. Oral histories recall the day the sea came or the night the mountains split. These stories passed down through generations carry truths that science is only now beginning to verify. The Earth speaks in many languages, and not all of them are written in equations. Some are sung, some are carved, some are remembered by those who live close to the land. Even now, cities grow near the edges of sleeping giants. Naples rests near Vesuvius. Tokyo stands near the triple junction of tectonic plates. Jakarta, Manila, Quito, and many more rise on soils made fertile by ancient eruptions. There is risk in this closeness, but also a kind of understanding, an old, quiet agreement between people and the land. We live here, with you, not above you. We farm the ash, we drink from the springs, we listen, and in return we prepare, we build better, we respect the stillness. We do not forget that one day the giant may wake. So let us not fear the giants nor pretend they do not exist. Let us instead learn to dwell with them, to listen to the earth's silence as closely as we listen to its storms, for in that silence there is wisdom, the slow wisdom of stone, of pressure, of heat held just beneath the surface. And perhaps the greatest lesson of all is this, that the earth is not finished, that it is still becoming, that even when it sleeps, it dreams. Let us now return to the surface gently, slowly, with the understanding that even in stillness the earth is never truly at rest. The sleeping giants beneath us remain wrapped in silence, but it is a silence that pulses, it breathes, it stretches across continents and beneath oceans, through mountain roots and ancient rift valleys. It is the kind of silence that carries memory, not the memory of moments, but of ages. And when we walk upon the ground, we walk not just on soil or stone, but on the patient backs of these giants, whose long sleep is part of the earth's rhythm. Some of these giants have not stirred in tens of thousands of years. Others have dozed for centuries, waking briefly only to sigh a plume of ash or ripple the ground with a passing tremor. Their stillness has allowed forests to grow on their slopes, cities to rise along their edges, and myths to settle into the stories of the people who live nearby. Yet their shape remains, the graceful dome of a once fiery volcano, the long fault tracing across a valley, the hot spring that whispers through the moss. These are not ruins. They are the outlines of a force not gone, only paused. The people who live near these giants often carry their memory without even realizing it. A child playing in a field may not know the ridge beneath her feet is an ancient lava flow. A farmer tilling the soil may not know the ash that feeds his crops came from a mountain that once darkened the sky. A city skyline may cast its shadow across the mouth of a caldera so wide, so old, that only satellites can see its true shape. And yet they are connected, the people, the place, the giant that sleeps beneath them. There is something comforting, even beautiful, in this quiet companionship. To know that the earth has shaped us as much as we have shaped it, that our buildings rise because the land once fell, that our fields bloom because long ago fire fed the ground, that the water we drink may have passed through, stone warmed by the earth's core. This is not a reason for fear. It is a reason for reverence, a reason to move gently across the land, to listen deeply, to build wisely, knowing that the earth remembers more than we do. In some places the giants will stir again. They will shake the ground, open the sky, release the heat held for ages. The lava will flow, the sea will rise, the wind will carry ash into distant lands. And yet life will return, it always has. From every eruption, new land is born. From every quake, the crust heals. From every silence broken, the earth begins a new sentence in the long story of its becoming. The giants may sleep, but they are not ending. They are pausing between movements. And so we learn not just from their strength, but from their silence. We learn that the greatest power is not always loud. That change can come slowly, quietly, with no warning but a soft shift beneath our feet. That even the most solid ground is part of something that moves. And perhaps we learn this too, that we are not separate from the earth, but a part of its breath, a brief flicker in its vast rhythm, a moment in its great unfolding dream. The giants beneath us may not speak in language, but they leave messages in the folds of rock, in the tilt of hills, in the pattern of rivers that follow old faults. They tell us, I was here, I moved, I rested, I may rise again. And when they do, it is not punishment or anger. It is simply the earth, remembering itself, realigning, renewing, continuing. So let us live with humility, not in fear, but in respect. Let us listen to the earth, not just when it shouts, but when it whispers. Let us build our lives not against the planet, but with it, beside it, within its slow, patient turning. For the sleeping giants are not only part of the past, they are also part of the future, and in their long dreams, the next shape of the world is already being formed. When you stand in the quiet and feel the stillness of the ground, remember what lies beneath. Not danger, not disaster, but power, memory, patience, a giant at rest, a force that once roared and will again, and in the space between its steps, life flourishes, time deepens, and the earth, always becoming, continues to turn. Beneath the continents, beneath the crust and rock, there is water, not oceans like the ones we sail or swim in, but hidden water, locked inside minerals, flowing through deep stone, whispering through cracks in silence. Scientists once believed that most of Earth's water rested on its surface, in seas, rivers, ice. But now we know there is another ocean, deeper and darker, beneath our feet. It is not a sea with waves or tides, but a boundless reservoir held within the Earth's mantle, a place where water is not liquid, but part of the very structure of rock. This underground ocean doesn't flow in rivers, it's stored in tiny pockets, in crystals, between atoms, and yet its volume may be greater than all the surface oceans combined. It moves slowly, pulled by pressure, drawn by heat, cycling up and down over millions of years. When volcanoes erupt, they release steam, not just from surface water, but from this deep hidden sea. And when tectonic plates dive beneath one another, they carry ocean water with them, dragging it down into the mantle where it waits, locked in stone. The water in the deep helps keep the Earth's mantle soft. It lets rocks bend instead of break. It fuels the slow convection that drives plate tectonics. Without it, the Earth's crust might crack and stop moving, like an engine seizing in cold. This hidden ocean keeps the planet flexible, alive, in balance. It may also be the key to how life began. Deep in Earth's past, volcanic vents in the ocean floor may have mixed this mineral-rich water with heat and chemicals, creating the first building blocks of life in the quiet dark. Life, born not under the sun, but in the warmth of Earth's hidden heart. And so this secret ocean may not just shape the land, it may have shaped us. We cannot see this ocean, but we know it's there, in the chemistry of rocks, in the tremble of waves that pass through the earth, in the breath of volcanoes. The ocean beneath our feet does not rise and fall with the moon. It waits, it remembers, it flows through time, drop by drop beneath stone that was never dry. Let us sink gently now into that hidden sea, the one that holds no tides, no shores, but rests inside the bones of the planet. This ocean beneath our feet does not roar or shimmer in sunlight. It breathes in silence, in pressure, in mineral memory. Deep in the Earth's mantle, hundreds of kilometers below the surface, water is bound within crystal lattices, trapped in minerals like ringwoodite, a blue gem found only at those crushing depths. It does not slosh or flow freely, but exists as part of the rock itself, held in atomic embrace, waiting for heat and time to set it free. When tectonic plates slide into the mantle at subduction zones, they carry seawater down with them, in sediments, in pores, in the very structure of oceanic crust. This water sinks with the rock deeper and deeper, until the pressure becomes immense. There, the minerals that once held it begin to change. Some release their water, others hold it tighter. The mantle swells with this hidden moisture, and in doing so softens. It bends, moves, circulates. This is the deep cycle, not of rainfall and evaporation, but of stone and steam, of sinking crust and rising melt. And just as water is pulled down, it is also pushed back up. As mantle material moves toward the surface, pressure drops, and the water locked in rock is freed. It becomes part of magma, making it more buoyant, more explosive. When a volcano erupts, the steam it releases is not just from surface water, it is from the ancient ocean, carried up from hundreds of kilometers below. That steam we see rising into the sky is the breath of the deep earth, exhaled after eons in the dark. The existence of this deep water changes how we understand the earth. It affects how magma forms. It influences how continents drift. It may even play a role in how Earth maintains a steady climate, cycling carbon, shaping erosion, guiding the long, slow dance of rock and rain. Without it, the Earth might be dry and brittle, its crust fractured, its plates stuck. But with it, the mantle moves smoothly, the crust recycles, the planet breathes. And this water is not alone. It carries with it elements, hydrogen, oxygen, carbon, sulfur, building blocks of life. Some scientists believe that Earth's water may have come not just from comets or icy asteroids, but from within, released slowly over time by this deep cycle, rising drop by invisible drop through volcanoes and springs. The oceans on the surface may, in part, be the surface expression of a much older sea, one born in the Earth itself. In certain places, this hidden water escapes more gently. Hot springs bubble at the surface, warmed by deep heat, carrying dissolved minerals from far below. In regions like Iceland, Japan, and Yellowstone, these waters flow through cracks and faults, heated by magma and rising to form pools that steam in the morning air. They are not just warm, they are ancient. Their journey began hundreds of kilometers down in the quiet zone where rock and water meet. This deep cycle of water, from ocean to mantle and back again, is slow, taking tens of millions of years. But it is steady. It connects all parts of the planet, the surface to the deep, the sea to the stone, the rain to the rock. And in this cycle there is a kind of peace. A rhythm not felt in weather or waves, but in pressure and time. So when we look at the ocean, vast and shimmering, let us also think of the ocean we cannot see, the one that lies beneath, held in the dark, shaping the world from within. For even in the driest places, even in the deepest stone, water waits, and in that waiting it helps keep the planet alive. Let us rise once more to the surface slowly, carrying the quiet knowledge of the ocean that lives beneath. Though we cannot swim in it or sail its waves, this hidden water shapes the very world we walk upon. It moves through the earth not in rivers, but in cycles of pressure and melt, in the slow transformation of rock. And even though it is locked away, it finds its way back, in the breath of volcanoes, in the warmth of geysers, in the soft minerals carried by springs. The deep earth does not forget its water, it only holds it, for a while. This hidden ocean reminds us that the earth is not just a surface but a system, one that links sky and stone, cloud and core. The water we drink today may have once been steam rising from ancient magma. The ocean we see at the horizon may be balanced by another, buried deep in mantle rock. Every drop on earth belongs to this great patient cycle, one that stretches not just across continents, but across time itself. And so the ocean beneath our feet continues. It does not crash or roar. It does not shimmer or shine, but it holds us. It softens the planet's bones. It keeps the crust in motion. It shares its minerals with life. It connects the deepest stone with the highest cloud. And in its stillness it reminds us, not all water is seen. Not all seas rise in sunlight. Some flow in silence far below where the earth still dreams.